Okay, so today we are doing on your tutorial 1. Okay, you have marked your attendance already. There are 17 of you already marked, so that's fine. Okay, so before we start, are there any questions on tutorial on lecture 1? Are there any major questions on lecture 1?
No, sir.
Okay, the rest any? Let me see. You can post on the conversation meeting chat. Okay, I'll just use the PowerPoint as my whiteboard, my whiteboard or blackboard, doesn't matter. So the few things that you have to know will be, okay, what is your mean? Your mean here will means your average. How to calculate that? Your median. What is the difference between mean, median, and mode? Okay, how to calculate your standard deviation. Okay, so there are two forms of standard deviation. One is for sample, another one is for population. So you have to know the difference on your calculator. Okay. So these are the few things that you have to know well enough. Now, I will have to say that out of this whole BDA, the focus is on two things. One is the concepts, the concepts of your statistics. The second is your computation. So computation will mean that this is talking about the lab sessions. Okay. We are actually reducing the focus on the actual calculation. Okay. Actual calculation means how you do your workings. Okay, how you do your working, how you do your calculator. So essentially, the whole module, the focus is really on the lab session. At the end of the day, for biological data analysis, we want you to be able to use Excel or your computer to analyze your data. We do not want you at the end of the day to still use pen and paper to do your calculations. Okay, the tutorial is mainly for the concepts, much less on the actual calculation itself. So far so good. Okay, because in the past, when we are dealing with, if you have paper exams, yes, actual calculations, how you do your workings, is basically a maths exam to some extent. Okay, but there is no exams this semester, and we decide to change the focus more on how do you do computations. Okay, because very often at the end of the day, when you have your data, it's not going to be 5 or 10 numbers. It's going to be 200, 500, 1,000 numbers. You are not going to press your calculator for that. You might as well use your Excel for it. Okay, so far clear?
Yes, sir.
Okay, so then the next few concepts I would like to go through will be this mean, median, and mode standard deviation first. Okay, before we go to the actual tutorial, because some of you may not realize what is the difference. So what I'll tend to do is I'll go through the important concepts before I go to the question itself. Okay, can anybody tell me what is the difference between mean, median, and mode? Or what is mean, what is median, what is mode? Let's say, what is median?
So concerning the median, first we need to arrange the data in ascending order first, and then after that, we need to identify whether there is an even or odd number of numbers that are given in the data,
Okay.
and an even number of numbers given in the data, then we need to take that number divided by 2 and also include that value plus 1. So basically, it will be two numbers at in two consecutive positions for even, and for odd. If there's an odd number of numbers, then we need to take that odd number plus 1 and divided by 2 to find out the position of the number first, sir.
Okay. Okay, so basically median is you sort the data points by either ascending or descending order, it doesn't matter. Descending. Okay, the second part is you find the 50th percentile, the middle number. Okay, so that's it. It's actually the 50th percentile. Median is actually the 50th percentile of a sorted data point. Okay, how about mode?
So for mode is the number which appears the most frequently in the set of data, sir.
Okay, most common or most occurring number. Okay, so that's it. Your mean itself, most of the time mean we are talking about average. Okay, there's other mean. Average is in reality this thing known as arithmetic mean. Arithmetic mean. Okay, so basically you generally use the symbol x subscript I to denote the data points. Okay, so average, the mean has this symbol called bar x. So the way to calculate it is a summation of all the x values from I equals to 1 all the way to n, divide by n. So that's actually your average. Okay, so this formula basically tells you how to calculate average. Okay, x is the data point. So you can have 5, 10 data points, just sum up everything together, divide by the number of data points. Okay. So if I were to ask you, how many data points you need to calculate average? What is the lowest number of, what is the minimum number of data points you need to calculate average? What, what did I do? What is the I would say least number of data points to calculate average?
So may I ask, would the least number be at least 2 points, sir? At least
so
2
basically, how many data points you need before this equation will fail? What is the least number of data points before this equation will fail? Meaning to say that if I put one data point inside here, will you get an answer for mean? Or do I need to put two data points?
So if we had just 1 point, then we would divide it by 1, sir. Or...
Exactly. You have 1 point divided by 1. So the least number of data points to get the average result is really just 1. Although it doesn't make a lot of sense.
Oh, yes, sir.
But that's for the equation to work. Because what I want to show you is, then if you look at the equation, okay, so before I go to this equation part. Maybe in the meeting chat, you just tell me if you are, who are fear, how many or who are fear, okay, who is fearful of mathematics? Who is scared of maths? You can tell me in the meeting chat. You can say me, I'm scared of maths. That's fine. Anyone scared of maths? No one? Okay. Now for standard deviation itself, the equation will be this: summation of, you have your x minus the average square divide by n minus 1, the whole thing square root. So this is the equation for sample standard deviation. So this is for sample standard deviation. Okay. For population standard deviation, it will be this. Okay. So that's why you cannot use the wrong, you cannot press the wrong thing on the calculator, because one is n minus 1. Okay. Now my next question is, just answer me yes. Just answer me in a few seconds. How many data points do I need for standard deviation? What is the least number of data points that I need for standard deviation? 1, 2, 3, or what? What is the number?
So would it be correct to say that we
Just tell me the number.
data for standard one, sir?
1. If you have 1, you have the denominator is n minus 1, you know, it's 1 minus 1. Can you divide anything by 0?
No, sir. So
No.
we need at least 2.
Correct. You need at least 2 here. Okay. You need at least 2 here. Any problem with this? You need at least 2 data points for your sample standard deviation. Now, the problem is this. In order to calculate sample standard deviation, first I need the mean, because you have to, the data points minus the mean, square it, add up together, divide by the n minus 1, and square root the whole thing. Okay, so can somebody then explain to me in 5 seconds, why do I want to square and square root?
So when we square the square root, then it makes the data easier to read, because when there's a square, then when we expand it out, it's more confusing, sir.
So you like confusion? Okay.
No, so I meant to reduce the confusion. That's why we square root the square.
Okay. So let me just show you another example. For any data, okay, so we don't bother, any number of data, okay, so before I go through that, anyone still is confused with what average means? What is average? How to calculate average? Okay, if you never type in the meeting chat, then I presume that everyone is okay. Anyone tell me that you do not know how to calculate average? Okay, any other respondents other than Sean? All know how to calculate average, right? Okay. Since you know how to calculate average, then let me try asking you for any number of data points. Maybe you have x, 1, all the way to x10. Okay. If I were to take this summation of x of the data points minus the mean itself, what will be the answer? If you can answer this question, then you know what average is talking about. What is really average? Any data points, there is only one answer for this equation. Anybody would like to try?
So would it be correct to say that for this particular value, it will represent the total value of all the given data points?
Which is what?
It's
Which is what? Which is,
the sum of all
no,
the.
it is an actual number. There's only one value. Will hold true for any number of data points and any number, whatever data points you have. Anyone can want to give a try?
So would it be the population size?
No.
The total?
No.
No.
There's only one answer here. Oops. Okay, there's only one answer. That's the thing. Okay, the answer is actually 0. Anyone can see why is it 0? If you take all the numbers that is before the average, you minus it off, will give you a negative number. And then you take all the positive number minus off the mean, it will give you a positive number, but the two magnitudes are the same. So you minus off each other, that's what average means. You end up with 0. Right? If this is the average, you have all the numbers before that. Here you have a minus a certain value. Okay, let's say minus y. Here you have another value which is z. You minus off itself. Okay, all these value minus off the average, and all these value minus off the average. Y will be the same as z. It's just the signs are different.
So may I ask, does the Z represent standard deviation?
No, it's just a number. Number.
Z is just it can be any values or.
Yes.
Or
Okay. So the question I want to ask you is, why do we square and square root the sample standard deviation? What is the purpose? Is the purpose to get rid of this problem? That means to get rid of the negative sign, because if you have the purpose to get rid of all these negative sign. Is that so? So that you don't get to 0. You get to 0, nothing works, right? Okay, because if you have 2, let's say the average is 5. Okay, so this will give you 2 minus 5 minus 3 square, give you 9. On the opposite side, you can have 7 minus 5 square. Here will give you 4 square, which is no, 2 square, which is 4. Is the purpose of square and square root just to get rid of the negative sign? Just answer me yes or no.
yes.
I don't.
Yes, sir.
Yes, okay. So it seems to be getting rid of negative sign, right? But let me ask you, out of this whole equation, can you do square and square root by hand without a calculator?
No, sir.
It'll be very, very tedious. Okay.
Yes, sir.
So the problem is, instead of square and square root, is there another mathematical operation to get rid of negative signs?
So if we had another negative sign in
Okay, so my question is,
front of a negative sign, it will be a positive.
yeah, is there another way to turn negative values into positive values besides square and square root? You have learned that in maths before. Is there another way? Yes or no?
Yes. Is it times or divide?
Times or divide? Not, not really. How do you divide and get rid of the negative values? You can't, right? Let's say if the reason is this equals to 0, okay? If I do x, but I do an absolute, that will get rid of the 0, right? Make sense?
So may I ask, how does the absolute get rid of the
Absolute
0?
means if it is negative number, give it the positive number. If it is the positive number, remain as positive number. That's called absolute. It's just
Yes.
removing it's just, if there's negative value, just get rid of the negative values. Just give me the magnitude. So absolute, if you remember, how many of you never did physics before? Anyone never did physics? Absolute is essentially how do you change from a vector quality into a scalar quality. That is the first lesson in your Sec 3 physics. Okay. So is it easier to use absolute than square and square root? Yes or no?
Yes.
Yes, right?
With the absolute, it's not.
Absolute is so much easier, but why on earth we still square and square root? Okay. You will probably not know the answer, but let me just work things out for you, and you'll see why. Okay, so let's say I rewrite the equation. N minus 1, okay? And I just now you say that at least I need 2 data points, right? For this equation to work, correct?
Yes, sir.
Okay, so let's say I have 2 data points, x1 and x2. I put inside the equation and see what happened. Because x1 and x2, n is 2, correct?
Yes, sir.
Okay. So I do this. When I get rid of the square root, I square on the other side, right? So I square. So I have this 2 minus 1. Okay. And here I expand it out will be x1 minus so far so good. This step, no problem, right?
Yes, sir.
Okay. Then, because 2 minus 1 is 1, so I can get rid of it. So this becomes here. Does this equation looks familiar to you now? Something that you have seen before, but not exactly, but it looks something like that.
Yes, sir. It looks like a formula from the secondary school elementary mathematics.
Yeah, which is what lah? What formula is that?
So it looks like the A plus B, then a whole thing square, that formula which equals.
whole thing square. To some extent. So let me just reduce it further. If I say that this is A equals to x1 minus mean, right? And B equals to x2 minus the mean. I substitute it in, I get this. Can somebody tell me what is this for equation?
So if S square is equal to A square plus B square, then it will be equal to A plus B, then times another
No, it doesn't
A.
matter. Have you seen this equation before? What is it called? Or if I were to write it out, if I say that C equals to S, if I change this to C square, what does this equation looks like?
Pythagoras.
Theorem, right? I forget how to spell his name, Pythagoras. Okay, it is Pythagoras theorem. It's because of Pythagoras theorem, that's why we have this square and square root. In case nobody still do not realize, what kind of triangle Pythagoras theorem will work for?
So it will be for only right angle triangles.
Right angle triangle. Okay. How many of you by now you still did not realize that when you draw your graph, it's always a right angle triangle? It is because we force Pythagoras theorem into your standard deviation. That is why all your graphs can be right angle triangle. Otherwise, you end up drawing graphs that looks like this. And it becomes everyone will have a different angle. Because we force it into Pythagoras theorem, force Pythagoras theorem into this equation, that's why all graphs become right angle triangle. Okay, so it means that square and square root, to get rid of the negative signs, it is a byproduct. The real reason is because of dear Mr. Pythagoras theorem. So far so good?
Yes, sir.
Okay, so that is the main concept. Then, okay, so far we gone through most parts of the information that I need to cover here. Because why I need to explain this to you? The reason is, if you go university, you'll find that a lot of people don't understand why you need to square and square root. Now, it's a very important principle first. Remember, I told you, concepts is the more important part than the computation. Once you can understand the concept, things will be so much easier for you. Okay. I presume all of you have done your tutorial already, because you're supposed to do a tutorial first. Okay, so we don't bother on question 1. Let's go to question 2 first, because question 1 is more of the very dry concepts. So let's go question 2. 2A. A hospital decide to review the mean salary of all of its 225 managing directors. Is this a sample or a population?
Population, sir.
Why population?
So because the keyword in the question is of all its 25 managing directors. So
Yeah. Because of all, it makes it a population. Okay, so population here. Question 2B. Anybody want to give an answer? Is it
sample?
sample? So why is it sample?
Because they say it's a sample. Because maybe
It's really-
it's using it to sample for the study of all the physicians.
Correct. So you are saying that there may be more than 75 general physicians, right? So you're
Yes.
taking a group of it. Yeah, of course, it's a sample. Yeah, correct. It's a sample. Okay. So what happened here? Okay. Okay, so this you have the two answer. Anyone actually still confused with the concept of sample and population? Today is Thursday already, which later you are supposed to view the second video. I will actually explain this in, I think, one of the video, either second or third video. What is the difference between sample, population, and so on? Okay, so I might as well just scribble here. So why do we study what is a population? Why we cannot study population most of the time? Is there any reason?
So it's because a population has a extremely large size. So if we wanted to study the population as an entire whole, it could be very difficult to obtain accurate results.
It will be very hard because population can be infinite. Infinite. Okay, population can be infinite. Let's say I want to study the BMI of all Singaporeans. This itself is infinite already, because why? It may be a bit strange. Why BMI of all Singaporeans is an infinite population? Because I have no time limit. I never say that BMI of all Singaporeans that is still alive today, or born in 1980, or born in 2000. If I just say that BMI of all Singaporeans, it will mean that all those Singaporeans that have already been dead, or those that have yet to be born, the time is infinite. Until, of course, Singapore actually ceases to exist. Then it becomes a finite population. But even then, you're talking about all the dead people as well. Second is, a lot of our testing are destructive. Because it's destructive, it can be very expensive to do. Okay. The number is too big. So we want to take the population, we want to take a sample. We want to take a sample. So let's say my purpose is to find out, let's say, your blood glucose level. Okay. What will be the sample? Will be, let's say, the tube of blood that I get from you. Okay, maybe it will be 2 ml tube of blood. What will be the population? Right, I draw a tube of 2 ml blood from you. What will be the population?
So in this case, it will be very difficult to identify the whole population, because in order to do that, we may need to drain the entire body of blood.
So
that's
this
not
means
possible.
that the population is all the blood in you. Correct? I'm sure none of you want me to just bleed you dry just to know your blood glucose level, right?
Yes, sir.
Okay, so I take a tube of blood, but at the end, let's say I come up with a number, I do my experiment and say that it's 5.8 millimoles per deciliter. Am I interested in that tube of blood, or am I interested in the blood in you? Which one is my focus? Is it the sample or the population?
Using the sample to get information
the
for the
sample, sir.
population.
Okay, so my question is, this 5.8 millimoles per deciliter comes from your sample. But am I trying to say that it is only applicable to the sample of blood and not the blood in you? My interest is it the population or the sample?
So it could be representative of the 5.8 millimole per deciliter as well as of the sample, sir.
Okay, so I'm trying to say that this tube of blood, although it comes from the sample, it actually represents the population. Correct? Otherwise, why? That means I'm going to have problem. This 5.8 millimoles is maybe the blood in your right hand. The blood in your left hand may be a totally different number. Then I'm having a problem, right? So I want to base on the sample and make inference to the population. That is given the population, the sample must be representative. Okay, this is in your lecture 2. You'll talk about what is a representative sample, which means unbiased sample. So in order to get a representative sample, this is known using probability. The inference part is where statistics comes to play. The number from an analysis is known as a statistic. Okay, one with S, one without S. Okay, so far so good. This is how you hide these 4 concepts. Okay, the root word for statistic can be defined as status. The word statistics may be coming from the word status. Okay, so then we can go to your question 3. So what is the mean, median, mode, range, and standard deviation? Okay, how do you do this?
So to find the mean, we need to take the 37 plus 34, all the values there divided by 9.
Correct. So, okay, the question. So to make your life simpler and to make everyone's life simpler, anyone already have the answer?
Yes, I have the
So
answer.
mean, what will we need?
My mean is about $39.8.
Yeah, 39.8, correct. Your median?
40.
Okay, 40, correct. Mode?
40 as well.
Okay, because
40
mode at this price, right?
Yeah.
40. Range?
13.
13, because it's highest minus lowest. Okay, so this is where standard deviation.
I got 3.99.
So that
Do you get
3.99, sir.
Yes, I got.
Correct. Okay. So in this case, it's up to you. You want to use your calculator or you want to use Excel, it's fine by me. Similarly, for your online assessment, right? You want to use your calculator or want to use Excel, it's also fine by everybody. You have the tools. So why not we take this in Excel and see what we get? Okay, we have this. So we want to find the mean, which is the mean. What do I have? Median, mode, range, and standard deviation. Okay, so this is what we want to find. Now, another advantage of doing online learning in this way is, in case you never realize, if you find my explanation is not good enough, you have 4 other classes to view. Okay, so the onus a lot deals with yourself now. In the past, if you are in class, you can only be in one time and one place at the same time. But now you can go and view all the recordings from M1 to M5. Okay, so you can look at how different lecturers actually explain the same thing. So the mean, have you, so you are M2, so you have done your practical already, right? Your computational lessons.
Yes,
Done.
this
Okay, so
Tuesday, sir.
Tuesday. So you actually know how to do all this. So the mean is the average. This is the median. The median is the function median. Okay. Mode is the function called mode. So this is one way of doing things. Range, range you have to, there's no range function. You do use the maximum minus the minimum. That will give you the range. Okay. And standard deviation, there's this standard deviation .p and .s. Please use .s. Okay, because .s is the one that is n minus 1. Okay, so it's 3.99. Or another method you can do is using the data analysis tab. Use your descriptive statistics. Okay, let me see if the video is still recording. I think it's still recording. Yeah, it's still recording. Okay, so use your descriptive stats. You put in all the data range, input range. There's no labels, so I don't bother. I want summary statistics. If you're on summary statistics, I get the output range. It's basically where I want the table to be shown. Okay, so I get okay. Nope, nope, nope. Doesn't give me this. Okay, wrong, wrong, wrong. Okay, mess it up. So let's do it again. Okay, because okay, now the data is grouped by row. So the row is the data. So I will change to the row. Okay, output range E3. Okay, so this is the data. Okay, it basically tells me everything I want to know. I have my mean, which is the average, standard error, median, mode, standard deviation. Variance is just the square of standard deviation. Okay, variance is just the square of standard deviation, which means that variance, you just remove the square root. That's what variance means. Okay, actually S squared means variance. Okay, S squared means variance already. So you take 3.99 multiply by 3.99, you get variance. Okay, kurtosis skew, you do not have to bother the range, minimum, maximum, the count, and so on. Okay, so there are two ways of doing it. Okay, so it's up to you. As I say, the last thing we want to see you doing is go and sort it out on pen and paper, because in reality, you are going to have a problem when you're dealing with actual biological data. If you happen to see me in year 3, because you are not going to deal with 5 or 10 numbers, you're going to deal with thousands of numbers. So you're not going to be able to sort by hand and calculate things by hand. Okay, so you get that? Okay.
Yes, sir.
Okay, so how about the next one? Question 4. Okay, can anyone, let's see.
So the mean will be 61.7.
Okay.
The median will be $56. The mode will be $53 and $56. The range will be $43. And the standard deviation will be 13.5. So.
Okay. All the numbers are correct. Hopefully you get all the numbers right. Anyone having problems? Anyone did not get all the numbers right? Okay. Then the next part is to ask you to compare the size, compare this question with that of the previous question. Comment on the bill size between private clinic and polyclinic. So what can you say?
So we can say that the mean, median, mode, range, and standard deviation for the private clinic is larger as compared to the polyclinics.
Okay, so number one is that is okay. Now, if you're going to, when I ask you to compare and comment, the easiest gauge is this: explain something that your grandmother can understand. Now, tell me, which one is more expensive?
The private clinics, sir.
Okay, good. Question one. You do all your analysis, you have to be able to put your conclusion in a simple language. Okay, okay. You can say that the average bill for private is more than your average bill for polyclinic. That your grandmother can understand, your mother can understand. Okay, you have to explain in a simple thing. Okay, it doesn't mean that saying too many things is good. Second is, can you comment about the range? Which one has a larger range?
The private clinics, sir.
So you have range and standard deviation, right? So the range of bills in private is also larger than the range of bills in polyclinic. Polyclinic. Okay, so that's it. You comment on the average. Which one is more expensive? Then which one has a larger range of bills? Okay, it means that when you go to private clinic, you first have a larger price, higher price to pay, and the range of the price is different. So you can have a very expensive bill for a common flu. So you look at the maximum here. Maximum for polyclinic, if you have a flu, as for the data, right, is $47, compared to you have $90, which is almost twice the price.
Yes, sir.
Okay. All right, so we done with this part. Okay. How do you do box plot? Using this data, do you know how to draw box plot? Okay, let me. Drawing box plot is nothing very sophisticated, so I must well just give you the answer for it. Where is my box plot? Box plot, box plot, box plot, box plot. Okay, so this is the answer for box plot. Okay, so this is answer for box plot. Okay, the main thing is the median is this dark line here. This is the median. Okay, the Q1 and Q3, this will be the third quartile Q3. This is the Q1, and then the maximum minimum will be these two. Okay. Now, very often box plot you need not draw by hand. In fact, we will use a computer to draw. But you have to be able to explain what, if given a box plot, you have to be able to explain what it means. Okay. If in event that you need to draw a sketch a box plot by hand, what I only require you to do is please draw it to scale. Okay, somewhat to scale. That means the range must be proportional. Okay, so box plot is not a problem. Okay, so here. Okay, so let's say knowing the data types, can you actually fill in the whole blank? That means what is, can you use proportion? Can you use central location? Central location means the mean. Okay, measure or spread, usually we are talking about standard deviation. So which one is logical? Can you use proportion for nominal data?
Yes, sir.
Yes, you can use proportion of nominal data. Does it make sense to do central location?
No, sir. Because
so
nominal is
it doesn't
because
have, nominal doesn't have a range.
yes, sir.
Okay, so nominal, the simplest one is you're talking about gender. Okay, male or female. You can give me a proportion, how many percent of this class is male, how many percent of this class is female. But it doesn't make sense what is the average gender. That means you're talking about, I don't know, 0.6 female in this, we have average of 0.6 female in this class. Sounds strange, right? If the,
Yes, sir.
if the central location is out of the question, then obviously spread is out of the question. Okay. Usually these two comes hand in hand with each other. So ordinal.
Yes, sir. There's a proportion for it, but no measure of central location, no spread, sir.
Yes, to some extent. So ordinal will very simply things like a scale of 0 to 5. Okay, that's ordinal. A scale of 0 to 5 or things like that. Okay. Interval.
There is proportion, there is a measure of central location, there is also a measure of spread, sir.
Alright. So interval will be things like your maybe count. Okay. Ratio.
There is proportion, there is central location, there is also spread, sir.
Correct. So all this will be useful. The difference between interval and ratio is the ratio actually have a actual 0. Okay, so there's a baseline. All right, any problems so far? Now you learn about the different type of measurements. So if it's a normal distribution, okay, normal distribution simply means, to your common sense, will be your bell curve. Okay, we'll talk about normal distribution all the time because if you know normal distribution well, every part of statistics is actually manageable because everything is based on normal distribution, and that's very important. So normal distribution will look something like that. Okay, your data will look like normally distributed. So there is asymmetrical. Asymmetrical, let me just, asymmetrical can mean different types. It can mean like a population that looks like that. It can mean a population that looks like this kind, or it can mean a bimodal population. Okay, those are not normal distribution or asymmetrical. So it asks you, for normal distribution, what is a good measure for central location? And for asymmetrical, what is a good measure of central location for spread as well?
So for the normal distribution, the central location will be the mean, and then the spread will be standard deviation.
Correct. Okay. Okay, can somebody else answer? How about the other two? You use up your mean already. It's like fill in the blanks, right? You use up these two already. Hopefully you know the other two. Which which one is a central location? Anyone?
So
Median.
Some other than Sean?
The central location will be median, and then measure of spread is interquartile range.
Yeah. So this can be interquartile range. Okay. Yeah. Okay. Okay. Besides, actually, who is the one answering the last one?
Me, Jeremiah.
Jeremiah. Okay. Are the rest still alive? You- Jeremiah. Okay. Are the rest still alive?
I don't know. So it's always like this when it comes to online lessons now. So you kind of get used to basically everyone more or less being quite quiet until you refer to them.
So I have to point people to ask. So yeah,
Kind.
right?
Yeah, I'm here.
Okay, so yeah, I start pointing people to ask. Okay, no problem. Next lesson, I'll just arrow people to ask. Jeremiah. Oh, Jeremiah Day. Okay. Yeah. All right.
Hello.
Hi, no problem. Okay, so now what we want to look at is response and explanatory variable. Okay. Which one which one is a response variable, which one is explanatory variable? Response variable. Hold on, let me just get there. Response variable is simply this idea. Okay. In maths, we have your general equation y equals to mx plus c. Correct? Okay. The response is y. Basically, you make y the subject, it means that the response is y. The explanatory is x. Okay. So what you will do is which one is the response, which one is the explanatory? Let's say for question 8A. So let me just arrow someone. Okay. Why not Jia En? You say? See whether you get the answer or not. Jia En, are you there? Yes.
Yes.
Yeah. Okay. So which one is the explanatory? Which one is the response for 8A?
The explanatory would be the effects of smoking. Then the response will be lung cancer.
Right. So smoking is the explanatory. The lung cancer is the response. Correct. Yep. Okay, so this is almost like using examples to explain what on earth this means. Okay. So if you go through all 5 of them and you get it right, you really know what is happening already. Okay, rather than explaining by words. So for B, let's say we pick one more person. Wei Qi. You should be able to answer this. Wei Qi, are you there? Sleeping. All right, we'll try Benjamin.
Okay, the response would be risk of having an asthma attack, and then explanatory would be obesity.
Yes. Okay. This is the risk. The explanatory will be the obesity. This will be the response. Correct. Okay. So for question C. Question C, who is next on the list? Okay, Felicia. Felicia.
The response is what will cause them. No, the response is dandruff. The
Okay.
explanatory is types of.
All right. Yeah, you're getting a handle of it. Okay. For D, Ihan.
The response is hiccups, and then the explanatory is the effects of alcohol consumption.
Yes. Oh, there's nice bird behind you. Okay. Okay, anybody have severe hiccups before? Anyone with hiccups? Or anyone love to have hiccups? That sounds like a horrible thing to have.
I've had hiccups before, but it mostly lasted for like a few, like I think longest for hiccup was an hour or so, but that's about it.
Okay.
I mean, I lost my voice once, so there's that.
Okay, there you can go to Guinness World Records and find who has the longest hiccup. I think it lasted for more than a few months. Yeah, so it's quite bad. I had hiccups for 5 days before, so it's horrible. Okay. For question E, let's say E, Grace. 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 Okay.
Yeah.
Okay, you're breaking up. You're breaking up. But speak slowly. Doesn't matter.
The response will be tooth erosion, and the explanatory is sports drink consumption.
Correct. So, okay, so this experiment is quite often done. I'm sure all of you have heard about people drinking your lemon water, right?
Yes, sir.
So lemon water, does it actually over time erodes your tooth? Okay, because lemon obviously is acidic, does it erode your tooth? Okay. So I will not go okay, I will say I will not go through. Let's just work out this. The only thing that I need you to know is we don't bother about stem leaf plot. Okay, don't bother about stem leaf plot at all. The reason why we don't bother about stem leaf plot is stem leaf plot is in the era whereby computers still have no ability to do graphics. So you're using like trying to print computer with words, trying to print a plot with words. So it's quite irrelevant. Now from this data, let's pick another one, because if you have the answer, then it's not a problem. Okay. Okay, Hugh, how about you give us the mean and median?
Okay, for 9B, the mean I got, okay, for mean I had, I think it's 1246.
Mean is 1246.
And median I had was 49.
1249. Okay, so median is 1249.
Okay.
Okay, the mean is not 1246. So the mean, let's just work it out. Okay, so let's go to your Excel. Okay, and you type in average, which is a mean. Okay, it says division by 0. This is a problem. I have to read because of the space. I think what you probably have is you misstep one of your yeah, but your median is right. Let's check your mean, because it is not the same as in my answer script. So I'm seeing whether it's the answer script wrong or the calculation is you have made a mistake in calculation. No matter yet. What did I do? It's 1245, correct. So the answer is a bit wrong. Okay, so 1246. So the median is 1246. Okay, so this is 1246. Okay. All right. Okay. So how about the Q1, Q3, and interquartile range? Let me just have Maximus.
Yes, hi.
Hi.
Wait, you want the IQR and mode and range, right?
Yes, IQR mode and range.
IQR is 58.
Yep,
I
58.
think there's no mode, and the range is 1, 2, 3.
Correct. There's no mode. The range is 1, 2, 3. Yep. Because mode, you need at least to have one more values. Anyone know how to use Excel to calculate Q1 and Q3? Okay. So let me just show you how to do that. Q1, you use the function called quartile. Okay, quartile. Now, quartile, it asks you for array. So you click on this FX button. It actually explain what on earth is it. The array means the data. Then the quartile, here you actually have to read, it's a number. If you want the minimum, you put 0. First quartile, you put 1. Median, which is the 50th quartile. Third quartile, and fourth quartile, which is the maximum value. Okay, so we want the first quartile is 1. So it gives you this number. That's the first quartile. Okay, quartile 2, which is also known as second quartile, is also known as the median because it's the 50th percentile. Okay, you just repeat this whole thing. And you change this from 1 to 2. That is the 50th, the median value is the 50th percentile. Okay, so this is a median. Quartile 3, just change this, the last operator or parameter to 3 because we are talking about third quartile. Okay, so this is the third quartile, and then your range is just the maximum minus the minimum. Okay, so your maximum minus the minimum. Now, I stress very strongly that you have to learn how to use Excel very properly. Okay, Excel is very useful. You have to use it correctly and properly. All right. Okay. So, are there any outliers? Okay. So, in order to find out outliers, you actually need a few different things. You need to find the upper limit.
So there no outliers.
Okay, correct. There's no outlier. The answer is no outlier. Okay, because the upper limit is Q1, or rather the upper limit is Q3 plus 1.5 times IQR in the quartile range. So this, if you work out correctly, will be 1359. Okay, the lower limit will be Q1 minus 1.5 IQR, which is 1127. So there's no values that's out of this range. So far, so good. Okay, so since this is already 10 a.m., I will leave you to, let's see, because the other two, question 10 and question 11 are similar. Okay, in fact, question 10, question 11, and question 12 are basically very similar. I will leave this for the, what I call, okay, maybe I'll just finish it up. Makes our life easier this way. So we'll go through the important parts. Okay, we don't bother about stem and leaf already. Display. Now our problem. Okay, so let's see. Okay, how to pronounce your name? Zoo what? Okay, I could just call you Zoo. Okay, any problem, Zoo?
Zul.
Okay, Zul. Okay, good. So, question 10. What is the median, IQR, mode, and range?
Median is 126.
Okay, so hold on. Correct, 126.
IQR is 18.3.
IQR is 18.3. Yep, 18.3. No problem.
Do you
Mode?
need the mode and range also?
Okay lah. Mode and range. Why not?
Okay. Mode is 119, 124, and 130.
119, 124, and 130. Correct.
And
Wait.
range is 49.
49. Correct. Okay. So, why not you say that are there outliers? Okay, so yeah, Zhu, just tell me whether are there outliers.
Oh, sorry. No, don't have.
Okay, no outliers, huh? Okay, correct. Okay, because the range is between 93.05 to 166.25. Okay, so there's nothing outside of this range. Good. Okay, all of you are doing quite well. So let's go to question 11. Okay, question 11, let's pick. Jeremiah had done it already. Heiko? Heiko?
Hello.
Hi.
Yeah, median is it?
Yeah, the everything. Median first.
15.45.
Okay, median is correct. 15.45 because you have to take the 2 in the middle. Okay. How about the IQR?
Oh, okay. I got also, okay.
Yeah.
2.46.
Yeah, 2.46. Because IQR is just this one minus each one, right? Okay. Outlier? Is there outlier?
Hello?
Yeah, is there outlier?
Oh, okay. Yeah.
Which one?
9.5.
Right, 9.5 is the outlier. Okay, because the range is between 10.13 to 19.97. All right. So if you were to ask to draw a box plot, this is how the box plot is supposed to look like. You have a box. Okay. So the median is already given 15.45. Okay. Here the third quartile is 16.28, 13.82. Then you have the whiskers. Okay, will be 17.8. Because actually it's 19 point something. You take the one that's lower. Okay, the next lower number. So this is 12.6. Because it's supposed to be 10 point something, but then you take the one that's before that. And then, oops, what do I do? Okay, anyway, let me just draw again. So this is 17.8. This is 12.6. And then your just mark across, say that it's 9.5. Okay, so this is your box plot. Okay, so let's go to last one. Okay, question 12. Okay, question 12. Okay, question 12. Mean, median, mode, mean, median, standard deviation. Okay. So this one is irrelevant. Okay. Okay, Hui Ping.
Mean is 81.8.
Hold on. Mean is 81 point what?
8.
Okay, 81.8, correct. Median?
85.0.
85.0, okay. You don't need to give me 0.0 because it's just one number.
Okay.
So standard deviation?
7.65.
7.65, correct. Yes. Good. So these are all the answers that you have. Any issues? Any problem? Okay, so I'll leave you, this is the end of the tutorial, and you can go and view, the rest of the time will be viewing the lecture, e-lecture for the second lecture. Okay, that's all for today. So how we will run the tutorial is this. Early part, I will clarify some of the things that is not that you have for the lecture itself. So next week is tutorial 2. So we'll clarify things on lecture 2 as well. And what are some of the important points that what I had today? We'll explain them before we go to actual tutorial. Okay, so far so good?
Sir, just to clarify, when we are drawing out the box plots, is it acceptable to just draw them with the x-axis and y-axis without like the other surrounding environment? Like usually when we draw the box plot, it's within a big square. But if we just drew out the x-axis and y-axis,
we can just do this lah. It's fine. It's fine. So this is yeah. The main thing is you draw the x and y axis. If you have more than one box plot, then it makes more sense. If there's only one box plot, then you don't really need it. Furthermore, remember, you have to realize that there is no paper exam. So you will never be asked to sketch a box plot. The only time you actually need to draw a box plot is how do you do it in your report. And doing box plot, this box plot in Excel is very, very tedious. Yeah, it's very tedious. Okay, so you have to know the principle. At least if you are given a box plot in a research paper, how you can understand it. Okay, but even then, there are many conventions of drawing box plot. Some people will draw box plot as these two are the actual range of the data. Okay, so you always, it's an actual range of data, then there is no outlier. Makes sense, right? Okay,
yes,
so you always have to, when you read box plot, because there are so many conventions, please read the figure captions. What does the whiskers mean? Is it trying to tell you the range or what? So always read the caption, okay? This is very important because you can make a lot of mistakes that way. All right. Okay, that's all. Yep. So remember, I'm sure all of you have marked attendance already. Okay, so that's it for today. See you next week. Bye-bye.
Yes, thank you.
Okay, bye-bye. Have fun.
Bye-bye.
Bye-bye. Stop recording and